Hello and welcome to this edition and this particular tutorial where we are going to talk about summarizing categorical data by using R. This is part of the using R features of the e-Pathshala Karyakram. And what we're going to talk here today is about how we can just summarize categorical data, but using R. So three basic things that we need to talk a little bit about. First of all, what is categorical data? What is meant by summarizing? And why it is important to summarize categorical data? And what about R for that matter? Now, if you are working in the fields of healthcare, engineering, any form of data analysis, there are a number of different ways in which the world can be explained, of course, using variables or using entities that are describe our experiences about the world, and these variables can be either categorical or continuous. Categorical variables are those variables which have individual levels that are distinct from each other. An easy example is gender. Gender has got two levels, male and female, and these are complete by themselves, and these are exclusive of each other. Another, for example, you can cut the continuous variable age into individual age groups. For example, less than 5 years, 5 to 9 years, 10 to 14 years, and so on and so forth. And you can see that in each case, these kind of exhaustively and completely and mutually exclusively describe the particular variable. So those kinds of variables are known as categorical variables. They're very, very important in order to explain the world in ways. We are learning R, which is a statistical programming environment and used very frequently for data analysis. And there is a need to describe the categorical variables and summarizing them. So this is what this tutorial is about. R, of course, is our software of choice. So we'll show and we'll see how these things work. Just a little bit about myself. My name is Arindam Basu, and I'm at the University of Canterbury School of Health Sciences. I'm going to teach you and walk you through these tutorials. One of the things that I'd really like to mention here is this, that when you work through these tutorials, make sure that you understand each of these steps. In these tutorials, I have provided you with R scripts. Use these R scripts for your own purpose and own learning purpose. Modify them and try to answer those questions. Okay. So what are we going to learn here? First of all, what we'll do is we will take a look at we'll read some data, and then we shall summarize the data. And the data that we shall summarize are categorical data, also known as discrete data. So if you see that there are some data that are discrete, then know that these are all categorical variables. In a subsequent lecture, we'll see how you can summarize continuous data, but here the focus is on summarizing discrete data. So the most important thing in terms of summarizing categorical data is setting up tables. That's very, very important. Tables essentially are very useful functions, and R provides you with a number of different routines and methods and different ways in which you can set up the tables. You can have a single variable for which you can set up table. You can have more than two variables for which you can have tables. And there are different ways in which we can do this. And so that's number one. And then we are also, by the by, going to look at just one simple instance where we can see that if we take two categorical variables and then try to describe them, what do we need to do? This is obviously somewhat beyond a purely descriptive endeavor, because we are going to introduce you what do we do in terms of hypothesis testing of two discrete variables in a subsequent tutorial. The objective of this particular tutorial is to just focus on describing a categorical variable and what are some of the strategies that we can use to describe them. So probably a visual depiction is not a bad idea, which we shall be showing you, but also in general giving an overview of the distribution of different categories that are quite useful. One of the things that we have not covered here is this, that when you get a categorical variable, a good thing to do is to use a bar plot as opposed to a histogram to describe them. But that's something that we can talk about in a second, right? So that's about it. And then at the end of it, once I have provided you with a description of what we are going to do, I will summarize everything that we have done. So this is basically kind of a motive that I'm going to follow, all right? So those are our learning objectives. And therefore, to recapitulate, we shall see that we will be reading data. One of the very important things is this, that we will let R to identify the categorical variables in a data frame. Another interesting thing that we might introduce in this particular section that we are talking about the categorical variables is conversion of a continuous variable into a categorical variable. Now, you may argue that this is probably not the best thing to do, because a continuous variable has its own routines and own ways of how we can work with them. So it's probably not in the best interest of converting a continuous variable into a categorical variable, but people do that all the time. So it's not always that bad an idea either. So we can convert a continuous variable into a categorical variable with X number of categories. Maybe this is a good place where we could introduce some of those concepts. It's not too bad an idea to do this. And then we shall be introducing you to a couple of different things. Of course, the most obvious thing is to use a bar plot, which you have already seen in the graphic section of these tutorials, this set of tutorials, so I'm not repeating them here. But something that I have not spoken of, that is the use of a mosaic plot, is something that I'm going to show you. So those are some of the things that we're going to do here. So the first thing first, in the next bit, I'm going to read a data set, and then after I read that data set, what we need to do is to identify the set of categorical variables that are present in that particular data frame. It's very important because you can identify them yourselves, somewhat visually, for instance, or by taking a look at that data frame or data matrix, or maybe you know them from some other source. But it is equally useful if you were to let the software kind of let you know that that they can identify categorical variables, and you can set them. And there are different ways of setting the categorical variables. You can convert a categorical variable and specify in R that there should be a factor level variable with X number of levels. The number of levels you specify there, and you name the levels. It's quite useful and quite interesting. So without much ado, let's do that. Just to jog your memory, of course, later on I'm going to introduce that you can use what is known as a foreign package and use that foreign package to read a data set which is formatted for example, another software for data analysis, for example, SPSS, and then you can read that particular formatted file into your system for use. This is something that we're going to do here. And then you can use a function which is quite intuitive to read them. So from top to bottom, let us read what I have done. The first thing that I've done is that I have loaded a library, and the library is called foreign. In a future tutorial, I'm going to talk about the foreign package and how to load the foreign package and how to use the foreign package. For the time being, just hold on to this thought. If you have installed a package, which is in this case foreign, by using install.packages foreign, then you can use this. Otherwise, install that package first and then call that package in your script by typing library within parentheses foreign, and then create an object called myData, and then use this particular symbol, that is a lesser than sign and a dash, and then type read.spss to type in the name of the file, which is in this case sidebike.sav, and specify that you're going to read it into a data frame. Now, after we have done that, I am interested to find out what variables in that data frame belongs to a kind of a categorical variable. And we'll take a look at this first. So we would like to really find out that there is a function called typeof. And typeof tells you if you pass an object to typeof, then typeof function will actually take as an argument name of that object or that entity, and typeof function will return what is a type of that object. If it is an integer, then you know that that integer essentially talks about, that is essentially a categorical variable because you got integer values. However, you can treat integer values as continuous, but here we're going to use categorical integer as a categorical variable. That's how we're going to treat that. Otherwise, if you type typeof and then pass as an argument the function of an object and that it returns factor, then you know that that is very definitely a categorical variable. Okay. So in this case, we use another function and we pass myData, which is the data frame object, and typeof, which is the function, as two arguments to that function, which is called sapply. And sapply essentially is an iteration function, which means that you take a list and then you take another function that you want to apply to each of this element of that list, which is called element-wise operation of that list. And then you pass those two things together to the sapply function, and sapply is going to then return element for element of that particular list, the result of the function that you want to apply. So here the function is typeof, and the list is myData, because myData is a data frame, but the data frame is essentially a list, nothing else. And then I apply the function typeof to each element of the myData by using another function called sapply, and sapply then returns it. So if we then use a third function, that is, if I print it out to my console, I get to see an output which is shown below, which is that the variable vehicle is an integer, the variable color is an integer, the variable helmet is an integer, helmet C is an integer, and the passing distance, that is an integer as well. So you can see that SideBike has got several of these things that are kind of integers. So C and F are two variables that are integers. So that's one way of identifying categorical variables. Well, that's not a very good way of identifying them, but you can coerce an integer level variable into a categorical variable, a proper categorical variable, by converting them into what is known as factor, which is something that we're going to see next. So here, what we have done is we have taken a continuous variable, for example, integer. We have treated integer as a continuous variable, and then we have converted that into a categorical variable, we have taken a helmet, which is kind of a continuous variable, and we have forced it to become what is known as a factor variable, a factor level variable, which with its own levels, and these levels are preserved. For example, we have created helmet underscore f as a helmet becoming a factor, and what we have done is that we have taken helmet and then we have converted that into what is known as a factor. Okay? So we've converted that into a factor level variable. We have forced it. Beyond this, there is another way in which you can convert a continuous variable into a categorical variable by using a very simple function called the cut. And here I have provided you with an example where you can use the function cut, and then you can take a double. This time it is passing underscore distance as a continuous variable, and then you can specify the breakpoints with which you're going to cut the particular variable. So I have summarized earlier the passing distance variable, and then I have used 0, 1.05, 1.28, 1.54, 3.54 as a 3 as these several cut points. And then I have specified that, okay, after I have cut them, these are the levels to which I'm going to coerce them. So I'll say less or equal to 1.04, 1.05 to 1.27, 1.28 to 1.53, and greater than 1.54. And so past dist is a new variable that I have created, and then I have printed a table of this. So this is where the summary bit comes into the picture. So the most important things that we need to do when we start working with this is how you can identify that a particular variable in a data frame is a categorical variable. If you see that the type of that variable is an integer, or the type of that variable is a factor, this is even a stronger evidence. And in order to summarize the information contained within that categorical variable, you use a very simple function which is known as table. So you actually force and convert that into a table. We'll see later that there are different ways in which you can form tables. So let us see how we can generate tables of categorical variables. The simple thing to do in order to tabulate a categorical variable is to use the function called table. Here, for example, we have got a variable called vehicle, which is essentially a categorical variable, and I have just used the function table in order to transfer or transform that into a simple table. When you do that, you just get the raw numbers. So if you use table of a variable, and then if you print that, then you will get, and I leave that exercise to you rather than I showing you this, but later on I may be showing you some of these things. if you then go ahead and run print table vehicle, you will see that this table is only going to give you the raw numbers of each of the level of the categorical variable vehicle. In order to generate the proportions of each of these levels or each of these categories of the categorical variable, you use another function called prop.table. So prop stands for proportions of that table. And instead of passing the table as a variable, or instead of passing the variable into there, you pass the argument of a table object. So which means when you convert it into a table, you are actually converting that into a matrix. And that matrix is an argument that you pass into that prop.table function, so that that matrix will now create its own proportional representations of each of these categories that go into there. So prop.table, the table object, then you multiply that by 100 and you get the percentages of each of these individual categories of that matrix or the table. But in real life, in order to summarize or describe the many levels of a categorical variable, you have to coerce both the raw numbers as well as their percentages. So you've created the percentages, and now you have to coerce the raw numbers with the percentages so that you can have a table with numbers and percentages. So for that, we use what is known as a column bind of two matrices, put them together, let's say C bind, then we put the table vehicle, which is the matrix of the product of the table function, and we create the prop.table times 100, the proportions, and then we bind them together. In this way, we get a very neat table with the raw numbers and the percentages. You just do it yourself and can see what I mean by this. This is when you have one variable to worry about. What happens if you've got more than one variable? So you've got two variables, you've got more than two variables. You use another function, which is known as xtabs. So what you do is that you create an object. In this particular case, we have got table underscore v h underscore call, and then we assign, we create that object, and then we assign that to a product of a function, and that function is xtabs, and then we put a tilde mark, and then we put the name of the variables that we want to produce cross tables, in this case color and vehicle, add them, put an addition sign between them, and specify the data object where they should be found, and that's about it. It's going to create a cross tabulation for this particular vehicle. But there is something very interesting about this. If you do this, then it will give you and then you can print the table, and you can get pretty much the raw numbers. But what becomes very interesting here is this, that you can actually then extend the number of variables by passing them as argument and by adding them using a plus sign, all categorical variables, into the xtab functions, and then specify the data object or the data frame where they will be found. And you can then very quickly expand the scope of this the categorical variable descriptions, where they're going to do this by the levels of the third variable. Very, very useful. What is also very important is this, that you can actually do a number of different things. One is, of course, you can then do some tests of independence, and the way to do that is you can use a summary function, and a summary function will run and test of independence, in this particular case chi-square tests of independence, and we shall be seeing that what are some of the other tests of independence that you can do, and you can easily then produce all the reports and results. And because the xtabs function produces an object, you can then subset, and then you can create functions by which you can then produce the percentages of each of these cells, and you can make some good use of that. The last thing that we're going to talk about and discuss a little bit is about how you can visualize categorical variables. That's very, very important. So let's take a look at this. In general, if you were to deal with only one variable, and if you were to take the, say, the proportions of each of these ones, then you could use the table as an argument to a bar plot, and you could kind of provide the bars as tabular data. And we have already visited bar plot in a previous tutorial, so I'm not going to repeat that, but you can use that. The new thing here is this, that you can use a package called VCD. If you have not installed it, you install it. It's called a VCD package, and then you call that package by library within parentheses VCD, and then you create a mosaic where you take two variables together, and then within the category of the second variable, you will be able to see the proportions of the first variable, and then you can shade them in different ways, and you can create what is known as a mosaic plot. It's kind of a heat map of one variable within another. It's very, very useful. So you could see, for example, vehicle and color, and you can see it in the next slide. You can see how it is. Okay. The best way to do that, of course, is to use your own categorical variables and run them, and see how the different categories are going to play up with the categories of a second variable. So let us conclude this. In summary, we have learned that we can identify categorical variables from within a data frame. We have learned that you can convert a continuous variable into a categorical variable by using the cut function, and then by using a cut function and then specifying the breaks. The simplest way to summarize categorical variables is by tabulating them. And if you are using bivariate or more than two variables, then use the xtabs function, and you can use mosaic plots, or you can use bar plots in order to describe the categorical variables visually. So this completes our tour of the summarization of categorical variables. Please practice using the codes that I have provided with this tutorial. Thank you very much for your attention.